Rational zerom theorem. Okay, first of all, you guys, what does rational mean?
Fraction.
All right, rational means fractions. Okay? Now, any number can be written as a fraction. -2 can be written as a fraction. 2/3, they all can be written as fractions, and they're all rational numbers. 0, that's where it crosses. Those are x-intercepts. Okay? And all of this, you guys, has to do with polynomials. Okay? That's what this whole chapter is about, is polynomials. So, what we need to do today is be able to identify possible rational zeros, not specifically, but possible ones of a polynomial function, and then actually to find all the rational zeros. First we have to identify them, then we have to find them. All right, let me explain this statement to you. This is like the formal definition. If p of x is a polynomial, p of x, you guys, is the same as saying f of x or y equals, okay? So just think of it that way. But it's a polynomial with integral coefficients.
What does that mean?
Basically, these are just numbers, okay? And they're negative, positives, rarely fractions, mostly just integers, okay?
Is that an apostrophe S or a apostrophe?
Numbers, that's an apostrophe S. Okay, so if you have just numbers as coefficients, remember, what are the coefficients? Yep, numbers in front of the x's. Then every rational zero of p of x is of the form p over q. We're going to get to what p and q means in a minute. A rational number in simplest form. P is a factor of the constant term, and q is a factor of the leading coefficient. All right, let's do some examples. First of all, p is the constant. Okay? What is the constant in this function right here?
-5.
Nope, what's the constant? The number, just the number. What is it? 7. This is p. Okay? What is the leading coefficient in this function?
1.
Remember, the leading coefficient is the number in front of the highest power to x.
1.
So it's 1. So this is q. All right. So first thing you have to do is we have to do factors of p.
So wait, is the constant just the one with the x connected to?
That's correct. Yep.
Factors P1.
Yeah, that's right. 1 and 7. But remember, you guys, that we can do plus and minus. Because remember, -1 times -7 will also get us a 7. So you always have to put plus and minus in front of them. Okay? Okay. Factors of q. What? What are the factors of 1? Just 1, plus and minus 1. That one's, they start you off nice and easy. Okay, so then what you do is you put the p's over the q's, which is plus and minus 1 over plus and minus 7 over, okay. Now, we have to write all the different combinations. And this is how I write the combinations. I take the first number and I say, what is 1 divided by 1? 1. So I write down plus and minus 1. And then I take the second one and put it over the denominator. What is 7 divided by 1? 7. Okay. +1, -1, +7, -7. Those are all the possible rational zeros of this function. Okay? That means that this function right here crosses the x-axis at rational places at either 1, -1, 7, or -7. One of those guys, or many of them. Okay? Does that make sense? We're just looking for possible ones. We're gonna test them later on. All right, take a look at this one. What is Q?
8.
Okay. Q is 8. What is P?
3.
Okay, P is 3. Okay, let's go over to the side now. What are factors of P?
1,
Yeah, okay, plus and minus 1 and plus and minus 3. What are factors of 8? Or Q? Okay, plus and minus 1, plus and minus 8. What else? 2 and 4. So plus and minus 2 and plus and minus 4. There we go.
Yeah.
That one has a few more. So now, go over here and we have to put all the P factors on top of the Q factors. P's are plus and minus 1 over plus and minus 3. Over, this one has quite a few. Okay, so you list them all like that. First you just write them like this. Then we have to go through and list them separately. Okay? And again, in the homework, in some of the problems, they're just going to say, list all the possible rational zeros. And all you have to do is list them. You don't have to test them. Later on, you're going to have to test them to see which one works.
So right now we're just listing.
Yeah, we're just listing. Okay? Now, we're going to do exactly what I did up there. Here, I put 1 over this, 1 over that. Marcos, you have a question?
Do you have to put them in order?
No. Notice how I did 1, 8, 2, and 4. No, I just put them in there how I partnered them up. Okay, so they don't have to go in order. Okay. Now, I take this first one and I put it over each of the ones down below. So, 1 divided by 1 is 1, so that's plus and minus 1. 1 over 8 is just 1/8, so you have to do plus and minus. This is where that lovely rational, because we've got fractions going on. 1 over 2, plus and minus 1/2, and then 1 over 4, plus and minus 1/4. Then we have to go back and do all the 3's in the numerator. Okay, so plus and minus 3, right, because it's just 3 over 1. And then 3 over 8. And then 3 over 2. Yes, it is. How many are there?
8.
But remember, there's 2 of each of these, so there's really 16.
That equals.
And this is to the 5th power. So what's the most number of times that this can cross the x-axis? 5. What's the least number of times?
1.
It has to go through at least 1. In the problem up above, what's the most number of times this could have? 6. And what's the least number of times?
0.
0. Because remember, even ones could be above or below the x-axis. Okay? All right. Okay, everybody have those? All right. Now what we are going to do is we're going to try to go through and we are going to find all the possible zeros. Then we're going to use synthetic division to completely factor the function. Okay? You know how we did on the previous page where we found a 0 and we tested it? We're going to do that. Then we're going to list all the zeros of the function. Use what you know about end behavior, and we're going to sketch the polynomial. So we're going to do 3 things for this function. Are you ready?
Yeah.
Yeah. Oh, that was enthusiastic. May I turn the page?
Yeah.
Yes? Okay. Turn the page. Here we go. This is the function. I just retyped it for us. First thing I want us to do is let's list all the possible P over Q zeros. All right. What are the, first of all, factors of P? What is P in this case?
8.
8. Okay. And we already did that. What are they again? plus and minus 1, plus and minus 8.
4, 2.
Okay, now you guys know why I did not give you a lot of homework, because sometimes these take a while. All right, then what are factors of Q? What's Q equal this time? Oops, 9. All right, so what are the factors of that?
3, 1, 9.
Okay, plus and minus 1, plus and minus 9. Oh, just 3. That one doesn't have a partner because it's 3 times 3. Okay. Now, here we go. Let's do P over Q. So, P, whoops, can't see that. I'm just trying to use all the paper possible. P over Q equals, all right? First, let's start and put all the P's on the top. What are they over here? Okay. 1,
1, 8, 2.
8, yep, 2 and 4. Good. And then I've got 1, 9, and 3. Okay. It's going to be a few, so let's list them all. And we just kind of go through it and do the best that we can. Here we go. So, all right. First off, 1 over 1, so that's plus and minus 1. Then let's go 1/9. Oh, yeah. And 1/3. Then let's start with 8. Yeah, how many are there here? Okay, then we go to 4. Okay, now. Yeah, oops, you missed all mine. There we go. What I would do first off is circle the whole numbers. Okay? When you use synthetic division and you start testing them, don't start with the fractions. You don't want to do synthetic division with fractions. So start with these whole numbers, okay? And so the first thing that you want to start with is, let's just try a 1, okay? So what we do,
Negative 1 and a 1.
well, let's just start with the 1, and if that doesn't work, we try -1. But it makes it a lot easier. So you start with a 1, and we try to see if 1 goes into this function right here. So what do I need to list along here?
9, negative 18, negative 4, and 8.
Yep, 9, negative 18, negative 4, and 8. Now, if you get this problem on your homework and they ask you to list them, go ahead and list them. Do you have anything at your disposal that could help you figure out maybe which ones go through nicely? What did we do on that note sheet that we just did?
Oh, the synthetic.
Well, when we had this and I graphed it, I was able to do what? Find out where it crossed nicely. I would graph this on my calculator and see which one of these whole numbers it crosses at, so then I could go down further. That's what I would do. But I'm going to go through and let's try 1. And, well, I guess we could, let's graph it and see which one to try. I don't have my graphing calculator. What do we have? Did somebody graph it?
Yeah.
Can I see it? Thanks. Okay, it looks like that. Okay? All right, and that's not too bad. All right, it looks as though if I did second table, do you see, there's a 0 right there at what?
0.
At 2, which means instead of testing the 1,
1 doesn't do that. I already did all of it.
okay, so you did all of it and you knew. 2 goes through. And I don't see any more 0. So we're going to do the 2 and see what what's left over. All right? So bring the 9 down. and it goes in even, sure enough. So, okay, what that means is that 9x cubed minus 18x squared minus 4x plus 8 equals x minus 2 is one of the factors. And then what is the other one? What's this 9? 9 what? I had a cube,
It'd be 9x squared.
and then
0.
minus 4. Is this the difference of perfect squares?
No.
Yep, that's a perfect square, that's a perfect square. It can be factored to 3x plus 2, 3x minus 2. Okay, now that I have these factors, John, what would I do to sketch this graph?
Just put it in the graph.
Yep, I got it, but I need to label some x points. Where's it going to cross the x-axis at?
2.
Yeah, no.
Negative 2.
Oh.
It's,
2. Wait, I crossed that 2 twice?
What's this 0?
Negative 2.
Nope,
Oh.
I got a 3 there.
Negative 2/3.
Negative 2/3. And what's this 0? Yep, it's a positive 2/3. Okay?
And behavior.
Yep, what is this function? Odd or even? Oops, well, let's go down here and write it in factored form. I'm probably getting ahead of myself.
Why can't you just back that? Why do you have to go through all the?
This,
Why you have to go synthetic and P over Q?
well, because since I saw that it went through at 2, I needed to know what was left over so that I could factor that nicely. Then I know what my zeros are.
Can't you just factor nicely from the beginning?
I know, but I don't know how to factor this cubic.
Yeah, we do.
You could eat it.
How? How would you factor that cubic?
Grouping.
Grouping? Let's see if it would work. Okay? I would take out a 9, and I'd be left, I'd take out a 9x squared, right? Watch, it's going to work.
Is it not supposed to work?
No, it's not supposed to work.
Will it work?
Nope, then I take out a 4. Yeah, it does work this time, Seamus. But usually it doesn't. And then I've got 2x minus 2's. And then I get 9x squared minus 4, which is what I had. Yeah, usually you can't factor it like that, Seamus, but that was that one
So
you
can I
could.
do that first? If it works,
Sure,
I should-
yeah, if you could do it first, go ahead and do
And
that.
if it doesn't, then you have to do this Q.
Right. Okay, let's put these dots back in here. 2, positive 2/3, negative 2/3.
2.
Is this an odd or an even function?
Definitely.
Positive or negative? What's the leading coefficient? Positive?
Yeah.
Okay, it's a positive odd function. Where's the end behavior?
Up or down, up.
This way and that way.
Down up.
Okay? So then what you do is you just go through.
What?
Up.
There you go. That's it. That's your function right there. That's all I'm going to be asking you to do. Okay? Got to place the zeros in, check out that it's positive odd, and then write, and then do your function. Okay?